In Python, variables consist of a name and a value. But there's a really important third characteristic of a variable, which is the data type. So variables can store different types of data. Let's see the most common data types, which are called primitives. First up is integer, or int, which can be any whole number. Floats are numbers with a decimal point and a fractional part. You can lose precision, but that's another topic. Character, or char, can contain letters, numbers, white spaces, and symbols. String is a sequence of characters. And Boolean, or bool, it has only two values, true or false, 1 or 0. There are languages which use explicit type declaration, such as C#. When you declare a variable, you need to declare its type as well. Let's see an example. I will declare a variable which is the age, that equals to 20. So this is the data type of my age variable, which equals to 20. C float, progress, my variable's name, my value is 0.9, float. Character, data type is char in C#, variable's name is letter, equals to, for example, m. String, name variable, and the Boolean looks like bool is reserved. For example, is reserved table, is the table reserved, and it's false. In Python, you don't need to actually declare that. It just gets figured out of your code implicitly. So Python has implicit type declaration. With Python, you just type progress equals 0.9, and it will know that's a number, a float actually. If you put quotes around the string, like name equals Adam, Python will know it's a string. Let's see how integer looks like. We already seen this. We had the money variable. Character, letter equals m, and Boolean is reserved equals false. Python has a type inbuilt function, which is used to determine the type of the variable. I will cover functions concept later. For now, I will show you how can you check what type a variable has. So now I create type of age, which will contain what type the age variable has. So I add the age variable as a parameter to the type function. And you already know the print function, type of age, and we will run this. And you can see age is an integer. Let's see another one, type of name equals to type function, parentheses, and the name parameter. And we will print this variable, type of name, run it. You can see name is a string. You need different data types for different program functions. Numeric data types can be used in arithmetic and logic operations. Character data types can be used to manipulate alphabetic strings. Data types determines what operations can be performed onto data. Every single data types have their own unique set of rules and instructions. Python knows what you can and can't do with the variable. Now I'm going to show you what I'm talking about through an example. Let's check out the asterisk sign, which means two things. Multiplication operator for multiply two numbers together, and the repeat operator for strings. So I'm going to create two variables, a equals 3 and b equals 2, and let's see what happens if I multiply these two numbers. So a multiplied by b, and let's run it. It's 6. It's easy. Okay, next thing, we have a again, it's 3, and now b will be 2, but as a string. Let's see what happens if I multiply a and b when a is an integer and b is a string. And now it is 222. When you multiply a string by an integer, Python returns a new string. This new string is the original string repeated the given number of times, currently 3. As you can see, Python behaves differently even if you do the same multiplication but on different types. That's one of the main reasons why data type is an important building block of programming languages. Sometimes there are use cases when you want to convert a data type to another one, such as converting a string to an integer. This is called typecasting, converting from one data type to another. There are two kinds of typecastings, implicit and explicit. Implicit typecasting is automatically performed by the Python interpreter. I create a variable a. This is an integer. Variable b. This is a float. And I'd like to add these numbers together as a c variable. So c equals to a plus b. And the question is, what is the type of the c variable? You already know the print function and the type function as well. So I will print out c's type. And this is a float. So this is an implicit typecasting because Python always converts smaller data type to larger data type to avoid the loss of data. Integer is the smaller data type and float is the larger data type. That is why C is a float. Now I'm going to show you what is explicit typecasting is about. A is now string, B remains the same as a float. I'm trying to do the same operation, which is the addition, so C equals to A plus B. Let's see what is the result, and the result is a type error. It says can only concatenate string to string and not float. Okay, so Python is not able to use implicit conversion in such condition because we can't add a string and a float together. In this case, you need to do an explicit typecasting. In order to do that, you can convert a to a float. In this case, the result is 4.5. So we are done. That's all for now. I hope I will see you in the next lesson.